To school cracker. Today's lecture will be on joint variation. First of all, let us try to understand what is joint variation. Three quantities x, y, and z. X can be proportional to y when z remains constant. X can be proportional to z when y can be constant. So that combining these two expressions, it can be written as x is proportional to yz. This is the first type of expression in case of joint variation. These three quantities can be considered again to express them as a joint variation in the other form. So x can be proportional to y when z is constant. X can be proportional to 1 by z when y is constant. So that is combining these two expressions, it can be written as x is proportional to y by z. This is the second type of expressing joint variation. The same three quantities can be expressed likewise. X can be proportional to 1 by y with z is constant. X can be proportional to 1 by z when y is constant. That is, when we combine these two expressions together, we'll get an expression x proportional to 1 by yz. So this is the third kind of expressing joint variation. Now I hope student can express three quantities as a joint variations. Okay, definition wise, joint variation can be defined as the definitions of joint variation simply reads like this. If three quantities are given x, y, and z such that x is proportional to y and z is kept constant, similarly x is proportional to z and when y is kept constant. So combining this statement, it can be simply written as x proportional to yz when both y and z varies. I will try to solve one problem related to joint variation. Let us consider an example regarding joint variation. Here the question reads like this: x varies directly with y when z is equal constant, and x varies inversely with z when y is kept constant, in such that when y is equal to 4, z equals to 5, then x is equal to 3. And in second case, when y is equal to 16, the value of z equals to 25, then we need to find the value of x in this case. So we know from the joint variation, it's given clearly, it's stated here, x varies directly with y when z is constant. So we'll simply write this: x directly proportional to y. Here z is equal to constant, and in second case it's written x varies inversely with z when y is kept constant. So here we can write again here x varies inversely with z. In this case y is kept constant. So combining these two expressions, we can simply write x proportional to y with z. This is the second case of expressing joint variation that I have talked earlier. So then we can further simplify this by removing the variation sign, introducing constant k. So here k is equal to variation constant. Let's try to find out the value of k by substituting the values. Substituting values. So I can simply write initially x was 3, y to be 4, and z to be 5. So I can find out the value of k here. So k to be equals to 15 by 4. Now in second case, considering second case, so can x is equals to k y by z. Again, here substituting the values, so I can simply get x to be like putting the values of k 15 by 4, y that is 16 is provided, and z to be 25. So I can simply cancel this out. 4 ones are 4, 4 fours are 16, 5 threes are 15, 5 fives are 25. So the value of x is coming out 3 fours are 12 by 5, 2, 2 by 5. So this is the way how we apply the variation, joint variation theory in problem. I hope student now you have understood how to express joint variation and to solve related problems regarding joint variations. If you have got any doubts regarding other two variations like inverse variation and direct variation, you can switch over to my other topics lecture in YouTube channel School Cracker. Thank you.